into the SQL session. So let you know like what is SQL. Okay, SQL, the acronym of SQL is Structured Query Language. The acronym of SQL is Structured Query Language, and this SQL is a standard query language which is used to communicate with the relational databases, which are systems that stores the data. Okay, which are system that stores the data in the table format. Like, also we can say that data is stored in the form of rows and columns. Okay, that's what a table is, right? So the data is used to get stored in rows and columns format. So as a BA, why should we learn SQL? Okay, how it is related with the business analyst work responsibilities. So SQL, as we discussed, SQL is just used to communicate with the databases. Okay, and these SQL statements are used to perform the task. Okay, used to perform some operations on the data. Used to perform operations on the data. Okay. Yes, yes. This recording will be uploaded in the YouTube. Okay. So SQL statements, so whatever the SQL queries or statements were there, those will be used to perform the operations on the data, such as we can insert the data and we retrieve means of fetching the data from the databases, and we can update or delete whatever it can be. We can do such operations by using this SQL, structured query language. So as a BA, okay, as a business analyst, we won't work on it. Okay, we don't need to implement the SQL code for like creating databases, but here we use SQL to retrieve data from the databases whenever it is needed. Okay, and in some situations, like where like for example, BA will be working in the different domains, right? Like banking or finance domain, whatever it may be. So PA has PA should know like how to retrieve data from the databases in case of any data related operations with it. Okay, at that time this will be useful, and so this is how like it will be related with the business analyst. So here we use, like in this session we are going to discuss or we are going to practice the tool, like in short we call it as SSMS. The acronym of SSMS is SQL Server Management System. Okay, so this is a like SSMS tool we are going to use today in the session, and it is just a application. Okay, so where this SSMS tool is a free integrated environment which was developed by the Microsoft, and in which it allows us to manage, access, interact with the SQL Server databases. Okay, so using this tool we can write and run SQL queries and explore the databases, and we can also create and modify the objects, means like databases, and generate the reports. We can manage security, backups, and resource. So these are the like general features of SSMS tool. Okay, so that we are going to discuss this tool in detail once you are done with the theory session. Okay, so before that let you know like terminologies of SQL. Okay, you have to know like terminologies of SQL. So let's discuss like what is data. Okay, what is a data? Data refers to any raw fact, okay, or figures like numbers, text, date, whatever it may be, which represents the information about something. Data is simply, we can say, it refers to the information about something. Okay, and what is database? What is database? Database is a structured collection of data that can be easily accessed and managed and also updated at the same time. Okay, database is a structured collection of data where the data can be easily accessed and managed and updated at the same time, and these databases stores data in an organized way so that users can retrieve it and manipulate it effectively, right? And these databases will be used everywhere, such as in banking or banking domain or healthcare or e-commerce or education, whatever it may be, in each and every domains or each and every field. So these databases nowadays, like each and every data is used to store in the form of the databases, right? Table form. Okay. And coming to data model. Okay. Coming to data model. So what is data model? Data model defines that how data is stored. Okay. How data is going to store and connected and accessed in the database. Okay. So this data model is nothing but it's just like a blueprint for designing a database. Okay. So let me give you clarity on this. So see, data models are of four types. Okay, it is again divided into four types. So first one is hierarchical data model. So where data is organized in a tree-like structure. Okay, where data is organized in a tree-like structure format. So here you can see the image like root, child, and for the child again we have the subchild like that, right? So it ensures the parent-child relationship between the data. Okay, so this is our hierarchical model. In this hierarchical model, data is used to store, and the next one is network data model. So what is network data model? Network data model is nothing but it is more flexible than the hierarchical data model, which allows the multiple relationship with each and every record or data, we can say, right? So in the image, in the visualization itself, we can able to understand each and every record, each and every data is related with the another data. Okay, so it ensures the multiple relationships. And the third one is entity relationship data model. And here data is stored in the form of entities, and each and every entity is related with each other. Okay, with a strong relationship between them. Here you can see the entity is connected with another entity. For this entity, uh, it might have the properties or characteristics of the particular entity, right? So that we can say attribute. Okay, and and the last one is relational data model. So which is currently most popular in the market. And in this relational data model, the data is used to store in the form of tables, like in the rows and columns format, and it uses keys, constraints, I mean like rules, everything will be applied on this relational data model. So here you can see customer is one table and orders is one table. So in the customers, we do have the three columns. Means these are the fields that you can say columns. So customer ID is one column, customer name, customer email. So whereas in orders table, you can see order ID, order date, customer ID, right? So if you observe here, so customer ID is common column in the both the tables, right? So here you can see customer ID is a primary key, and whereas the same customer ID in orders table, it is a foreign key, which ensures the relationship between these two tables. Okay, by applying these keys, okay, while creating the database itself, we should add these keys. Then only a relationship will get ensured between the tables. Okay, this is how data is getting related with the other tables in the database itself. Okay, even though it will be clarified while creating, and even I will explain with an example, using an example. Okay, and next thing is data types. Okay, so data types, what is data type? Data type is nothing but what kind of data that we are going to store in the particular column or field in the table. Okay, so what kind of data? So whether it may be a number or a text or both combination of a number and text. Okay, See here we do have the like various data types in the SQL. Here you can see here char, like the main the full name is, you call it as character. Okay, so this char is the predefined keyword. Okay, means a built-in keyword, so that like whenever we type char, then it automatically recognize that keyword. Okay, so char is the, like, whenever we use this char data type, so we can store the only the alphabetic data. Okay, only the alphabetic data whenever we use char data type. So here you can see like simple syntax for it. Okay, so if we use the size, means limit. Okay, so then we can store only the like up to that size only. Okay, we can use it to store the alphabets up to that size limit only. And if you are not using that much limit, like remaining space, like remaining limit will be filled with spaces. Okay, space is also one of the character only. Okay, so it doesn't mean the empty space is also one of the character only. Okay, so that's how SQL will consider each and every characters. And coming to varchar, so in the name itself, like variable characters. Okay, variable characters. Varchar in the sense like where we can store combination of alphabets and numeric data. Combination of alphabets and numeric data. For example, you can say email, right? For example, email you can say like name, like 123 at the rate gmail.com. Here alphabets are also getting used, and at the same time numbers and special characters like at the rate and dot or period operator, right? So each and everything will be used. So at that time we can use the varchar. Got it? So here also we can give the size. Okay, and int here you can see integers. Integer means like it can be negative values or positive values. Okay, both values will get stored in whenever you use the integer. Okay, int data type, and the default value would be the 0. Okay, if we haven't given that, then the default will value would be the 0. Okay, and decimal in the sense, for example, let's say salary. Okay, like we have LPS in like, right? So for example, 5.2, like 5.5 LPA, like that. So at that time we can use decimal, and the main benefit with while using the decimal data type, we can fix the precision, means like scale after the dot operator, how many digits that it should represent to us. Okay, how many digits that it should represent after the like dot operator. Okay, and whereas float also works in similar way, but we can't fix the scale or precision after the dot operator. By defaultly it can, it will present you like only one digit after the dot. Okay, after the like period operator. Okay, after that decimal point. Okay, so date, you know, like it stores only the date, so by default value, like default format like year, month, date. Okay, and we can also change it. Okay, and time, so this is like time, hours, minutes and seconds, and date, a combination of both date time at the same time. Okay, so these are the data types that we have. These are the like basic terminologies that we have in SQL. Okay, so here coming to this SQL fundamentals, like what kind of operations that we can do using SQL, and what kind of operations that as a BA we can do. Okay, so here in using SQL on data, okay, on data we can perform the CRUD operations or CRUD operations. CRUD, okay, CRUD. C for create, R for retrieve or read. Okay, R for retrieve or read. U for update, and D refers to delete. Okay, so these are the operations that we can perform on the database in the on the data in the database. Okay, so as a BA, like we use only read operations or retrieve operations. Okay, retrieving in the sense like fetching the data from, okay, fetching the data from the databases, right? So that's how as a BA we use SQL to retrieve data from the database. Okay, according to the requirement. And coming to the difference between DBMS and RDMS. Okay, difference between DBMS and RDMS. So before that, let me explain you one scenario so that we can map the differences with DBMS and RDMS. Okay. So for example, like imagine a person. Okay. Like let me consider yourself. So for example, if you went to any supermarket, okay, to buy vegetables. Okay, if you went to any supermarket to buy a vegetables, so for example, if all the vegetables such as tomatoes or potatoes or spinach, whatever it may be, are randomly mixed in a small large basket, like a single large basket. Okay, mixed in a single large basket. So then, as a customer, like it would, so it would be fine to difficult, right? It would be difficult and it will be time consuming to locate or to find out the specific vegetables whatever we need, right? And it would require going through the entire basket, and it leads to the inefficiency. So the same scenario, like now consider an organizer setup. Okay, now consider a organizer setup. Previously that was an unorganized setup, right, where each and every vegetable were mixed in a single basket, so that it would take it would be difficult to figure it out, and it would be like time consuming. So whereas in organized setup, so let's consider the same supermarket places each type of vegetable in separate labeled basket, like such as tomatoes in one basket, potatoes in second basket, like that, so on. So so this arrangement makes it quick and easy to identify, and at the time we can access it and pick the required items whatever we need with the minimal effort and with the minimum time, right? So here let's reflect the importance of structured data storage in databases. So for example, in the supermarket, when we consider a supermarket scenario, so all the vegetables were in the first scenario, all the vegetables were placed in one basket, right? Which means like unorganized each and everything. So if you map that, so coming to database, the unstructured or poorly designed data like in a file or basic, so that we can consider as a DBMS. Okay, so in DBMS where data is poorly designed or unstructured format, okay, it would be like time consuming and difficult to find it, like what actually the data we need. Okay, and in the same second scenario, vegetables were organized in labeled basket, right? So if you map that, then well structured tables. Okay, okay. So these well structured tables we can refer to the like RDMS, right? A relational database management system where it ensures the quick identifying the data, and access time is also very low, right? So in DBMS it is difficult to retrieve specific data, and whereas in RDMS fast query performance and easy navigation and retrieval will be there if we use RDMS, right? So in overall, like DBMS, where it stores the data in files or navigation forms. Okay, example, for example, hierarchical network models for a, let's say like here you had seen already hierarchical and data model. So where it might be difficult to find out the data what actually we need, right? If we use these data models, like it will be similar to the database management system. So whereas RDMS, so it stores the data in the table format, right? So the like in the form of rows and columns, where we can easily identify the data, right? And in the DBMS, no relationships between the data and tables. And in whereas the RDMS, tables are related using the primary key and foreign key. Tables are related with primary key and foreign key in RDMS. See here you can see, right, a relational database management system. Tables are related with like primary key and foreign key. And RDMS is sorry, DBMS is mainly suitable for the small organizations with the limited data, and it generally supports only one user at a time. Okay, only one user at a time. And in DBMS, more data redundancy due to the lack of relationships. Data redundancy is a repetition of data. Okay, so the data which is already existed in the system again, so the same data is will get stored. Okay, even though existing one is there. So examples of DBMS would be XML, extreme markup language files, and file systems like .csv, like comma separated value documents like that, and MS Access. So these are the like a general DBMS that we can say. And orally, we can say DBMS is nothing but simply a file based and no relationship between the data, and single user focus means only one user can access it at a time. So while coming to RDMS, so it is designed for the large scale systems and it can handle the large volumes of data, and it supports the multiple users simultaneously, and at the same time redundancy also minimized using normalizations and relations between the tables in the database. And for example, let's say like MySQL, PostgreSQL, and SQL Server, Oracle, SQLite. These are the examples of RDMS. So in this session, we are going to discuss about the SQL Server. Okay, SQL Server we are going to learn in this session. And orally, we can say RDMS is relational and structured, and we can say multi-user friendly. Okay, so this is how like the difference between the DBMS and RDMS. I hope you are clear with this. So SQL, what can SQL do? So SQL can execute the queries against the database. So that is the main purpose, right? Using SQL. So here we can write the query. Query in the sense questioning. Okay, query simply we can say query is nothing but questioning to the database. So whenever we perform, so whenever we execute a query against a database, then according to the query, it should provide the output to us, right? So that SQL can do, and SQL can retrieve. As you discussed, we can read the information or data from the database. At the same time, we can insert the data and update the data, delete the data. Okay, and also we can create the new databases, and in the databases also we can create the new tables. Okay, and we can ensure the relationship between the tables as well. Okay, so SQL can create a store procedure in the database. Store procedure in the sense, for example, let's say every time we need not to update the like data, right? So for example, if I insert a data, okay, for example, let's say consider any student result. Okay, so we can have the like marks, right? Subject marks scored in the particular exam each time. For example, let's say three exams were there. Okay, three subjects were there. So in the three subjects different marks were scored by a student. Okay, and so whenever I insert a record, okay, whenever I insert a record means like whenever I inserted a data related to the subject marks, okay, in the three subjects, so then automatically Automatically it should calculate the total and calculate the percentage. Also it should present the grade. Okay, so that's how it will works. Store process in the sense. Okay, so previously each and every like instructions were given to the database. So at the same time, like whenever I insert the data, so it automatically performs, automatically stores in the table for in that particular columns, means a total, percentage and grade. Okay, so whenever we retrieve data, automatically it should present each and every detail with all the details in the particular table. Okay, that's how storage processor will works. And SQL can create views in the database. SQL can create views in the views in the sense it is also a part of the table. Okay, it is also part of the table with few columns. Okay, few like specific columns that also we can select. Okay, it is also part of the column, sorry, part of the table. So for example, let's say like entire like student database is there. Okay, so we can create the view only with the specific columns like student roll number, student name, and the total he scored in all the subjects. Only these three columns we can select and we can create a view for this, only for these three columns. So these three columns also a part of the whole table, right, with all the details of student. Okay, so views are like it is a part of the table where we can select the few columns from that to create a view. Okay, so based on the need we can use this operation. Okay, based on the need we can use this feature. And SQL can set permissions on tables, procedures and views. Permissions in the sense like granting permission or revoking the permission. Like we can set the permission for the access purpose. Okay, providing the access to the other users like that. Okay, so not everyone has authority to access the data, to modify the data in the organizations, right? So that's how like SQL can set the permissions on the tables or the data on the. Okay, so here earlier we discussed the data in RDMS. That data is used to store in the form of tables, right? So what are tables? Table is nothing but a two-dimensional structure format where data is getting stored in the form of rows and columns. Okay, so here in according to SQL terminology, we call row as a record. We call row as a record and column as a field. Okay, here I can see whatever the horizontal data is there that you can consider as the rows. Okay, so the vertical ones, so id is one column. Okay, that we can call it as field. Okay, rows, whereas rows like one Will Smith like this address and this state as CA and one pin code 10011. Okay, so this entire data is we call it as a record. Okay, one record means one row, one field is nothing but one column. Okay, so here let's see like sample, like example for a primary key and foreign key. So here it is where I'll explain. So consider a retail store. Okay, in a retail store, here you can see like customer table, item table, and sales table. Okay, customer table, item table, and sales table. So these three tables were there in a single database. The database name is retail store. So customer is a different table, item is a different table, and sales is a different table. Okay, so these three tables are interrelated. Okay, in the database. So let's say like customer table, like we have the columns, like fields, we can say customer ID, customer name, state, city, pin, right? These are the fields of a customer, like customer properties are characteristics, right? And here if you observe, here you can see the like key symbol, means it refers to the primary key. It refers to the primary key. Okay. Why? Because so it uniquely identifies each and every row, means it uniquely identifies each and every row. Here you can see like 1 2 3 4. Here if you observe here, no values or no IDs were repeated, right? So each and every value whatever you have added, so each and every value is unique, right? It defines that. Okay, primary key use it to like uniquely identify each and every row. And in the same way, like in the item table, so item ID, item name, description of the item, right? So here also you can see primary key, right? Where each and only the particular column it has the primary key. Okay, not for every column, right? So if you observe here, for example, if a pin is there, here 10011 and 100, these are repetitive, right? So this means a redundancy. This means the redundancy. Okay, so like pin code can be same with any user, right? But not the IDs. IDs must be unique. Then only we can identify them, right? So that's how it will works in the SQL. And whereas sales table. So in the sales table you can see the primary key as well. And so these two, item ID and customer ID, refers to other column, refers to the column in another table, right? Refers to the column in another table. So this ensures the foreign key. This item ID, customer ID in sales table works as foreign key. Okay, which ensures the relationship between the tables. Okay, which ensures the relationship between the tables. So let's see like how we can read this data. Okay, how we can read this data. So sale ID is 1. Okay, so what was the item ID? Yes, foreign key is nothing but it refers to the primary key in another table. It refers to the primary key in another table to ensure the relationship. Here foreign key can contain the duplicate values as well. Okay, foreign key can contain the duplicate values, but not in the primary key column. Okay, see how we can read the data. Like sale ID is 1. Okay, so these sale IDs must be unique. Yes, correct. So item ID is 1. Like what is the item ID in the item table? Item ID, which was the camera, right? And which has the like 64 MP. That is the description of it. And who bought this product? Who bought this item? Like ID is 2, right? ID 2. Okay. Who bought this? Sean Smith. Sean Smith bought this item, right? With all the details here you can refer, right? So and how much quantities that he bought? 3 quantities and the price would be this, right? So this is how we can read the data. And at the same time, like sale ID was 2 and item ID. What is the item ID? Memory card, right? Memory card. And who bought this? Again, Shaw Smith bought this product. And what is the quantity? 1. And the price is 1500. And the sale ID is 3. What is the item name was camera. And who bought this? Will Smith bought this. Will Smith bought this, right? uh, so you can see the all the details of the Will Smith over here, right? So this is how we can read the data team. Okay. As I said, like in the primary key column, we can have the like unique values, and in the foreign key, okay, we can have the like duplicate values as well. Okay. So this is how we need to understand the data. This is how we need to understand the relationship between the tables, and this is how we can read the data from that. Okay, by combining all the tables. So generally, join statements will be used. Okay, join statements will be used to read the data from multiple tables at the same time. We use the join statements. So these are the advanced concepts. Okay, even I will explain with the example. Okay, no need to be worried on it. So let's discuss it in more clear way. Okay, I hope you are clear with this. So the main important concept in the SQL is commands. Okay, so in another way we can say sub languages of SQL. Okay, sub languages of SQL. Usually we have five. Okay, usually we have five sub languages. One is the DDL, data definition language; DQL, data query language; DML, data manipulation language; and DCL, data control language. And also we have the TCL, transaction control language. Okay, transaction control language we have. So if I present you that as well, see. So here were the in detail commands with all the details. Okay, so let's understand this. DDL, in the name itself, data definition, right? Where we can use these commands, these sub language to perform operations such as to create the databases or tables, and we can modify it, right? And we can delete the table, entire table at a time. Okay, those kind of operations we can do using this DTL sub languages of SQL, data definition language. So we have like generally we have create. Mainly you can, it clearly says that we can create the databases or tables, right? And alter. Alter means like the name itself, it altering, okay, or modifying the table which is existed. Okay, and we can also add the column or remove the columns like that. Drop table means it will delete the whole table or whole database, okay, at a time. And truncate, which will be used to delete all the records from the table, but table structure will remains constant. Okay, but the table structure won't get deleted, only the data will get deleted, all the data. Okay, all the data will get deleted at a time. And rename also will be there. So rename mainly used to like to rename the existing table or existing object, whatever it may be. Okay, and here you can find the syntax. So we can use this syntaxes while creating the while using the SSMS tool while running the executing the queries. Okay, at the time we can discuss that. So you can see like in simple language. So how we are communicating. So in the same way, we are communicating with the tool for the operation, like create a table. Also, we need to mention the table name. So what would be the columns for the table? Column name, right? And data type. Data type we already discussed it. For each and every column, what kind of data that we are going to store. So that we have to mention it mandatory. That is a mandatory thing. Without providing the data type, it won't get stored. Okay, it will directly provides you the error message. Okay, and coming to second one, DML, data manipulation language. In the name it suggests manipulation means modifying or manipulating the each and every data, okay, in the table. We can insert the data, update the data, delete the data. Insert means adding the new records into the table, and we can update in the sense modifying the existing data, right? Delete in the sense we can delete a single record. Single record means single row. Okay, rows. Okay, only the specific rows we can delete from a table. So the main difference between the delete, drop, and truncate is delete is used to uh, remove the records, means entire row from a table, and whereas truncate, which is used to remove all the records, okay, from the table at a time, but table won't get deleted. Okay, table structure won't get deleted. Again, we can insert it. Okay, whereas drop is used to delete the whole table itself. Whole structure of the table will get deleted. Okay, and data query language. What is data query language? Data query language, in the name itself, it is suggestion. Query means questioning, right? So what command we can use? Select command, which will be used to retrieve data from the databases. Okay, and data control language mainly uh, it ensures the like permissions, like as we discussed it, like we can set the permissions on the tables or databases, right? So it ensures the permissions like by using the two commands, which is a grant and revoke. Grant means like approving the permission. Revoke means redoing the permission, right? Removing the permission whatever you have granted. Okay, and TCL, transaction control language, mainly it will be used on the uh, like transaction, any banking domain like that. Okay, like payments like that. So it will be used to manage the transactions in SQL. After the DML operations in the sense like data manipulation languages. For example, after performing the like update or insert or delete, we can use these commands to save the particular like transaction record. Okay, or else we can partially save that. Okay, by using the save point, or rollback means we can undoing the transaction. Okay, we can undoing if any errors occur like that. Okay, so that's how these commands will be used. Okay, so here you have all the like in detail of that. So this is the tool that we are going to use, structured query language, like a server management system or studio, SSMS. In short, we call it as SSMS, which was developed by the Microsoft, right? So this tool will get installed. So you can refer to the YouTube channel. So go to the YouTube channel. Let's go to YouTube. In that you have recordings like COEPD, such as COEPD. Here you can see the channel. Okay, click on this. Please do the subscribe for updated videos or recordings. Okay, here you can see SQL server installation. Just type it. Okay, there will get the video like how to install the uh, SQL server in your system with all the configurations from the starting to end. Okay, so refer the video and install the tool and try to practice on it. Okay, work on the SSMS tool to execute the queries. Okay, I hope you are clear with this. So let's open this. So this is how tool will get in. Yes, yes, it will be shared in the YouTube. Yes, Sri Krishna, I'm on it. Okay. Uh, so team, just it is connected to local server. This is a laptop, right? This is connected to the local server. The server name is. So as of now, for practice purpose only, right? Here we are using the you're connected to the local server itself. Means your system, okay? Your local system, that laptop or PC, whatever it may be, it is connected to that only. Okay. Also, it can be connected there like live data also, but as of now, it is connected to the local system. Connect. Okay. Click on connect. So that's all. So this is the tool. This is the so MS SQL Server. As I told you, Avinash, once go to the YouTube and search as COEPD. There you will get the channel name Business Analyst Committee from COEPD. Okay, so go to the channel and search as SQL Server installation. There you will get one video. It is around 7 minutes of duration. In that, it is clearly explained that how to install the tool with all the configuration settings as well. So refer that. Okay, refer the video to get this tool in your system. So team, this is the like tool. Okay, this is the interface of the tool SSMS. So in the left side you can see object explorer, where it will be used to navigate the tables, databases, views, store procedure, each and everything that you can access over here. Okay, so how to create a databases? Just select it and right click on it. Right click. Okay, here you can see new database. Click on this. Again, I'm telling, right, select database, right click, new database. Okay, then you can see this prompt. Just give the database name. For example, let's say uh, SQL session on. Okay, so click on OK. Then your database be created. Here you can see highlighted one. Again, right click on it, select it and right click on it. So select the new query option, new query option. Then you can see this window. This is the query editor window. We can say query editor window. Okay, query editor window, which means where you can type and run the SQL queries. Okay, where you can type and run the SQL queries. Okay, so why this SSMS is useful? Okay, so it is easy to connect to the local or remote SQL Server databases, and it will be user-friendly interface with the syntax highlighting, and as well as it is a great platform for learning SQL and practicing the queries. Okay, so here you can say this is a query editor, right? So let's perform some operations. Let's try to create the tables over here. Okay, so SQL session, right? This is the database name. Yes, that's what I'm going to tell, right? So it is not connected with the how can I say live servers. It is connected with the local system itself. Okay, whatever the operations that I can do, all things will be saved in my system itself. Okay, so not it is not connected with the any live server, anything. Okay, it is just connected with the local system itself. Okay, that's what I had shown in the beginning while opening the like this tool, right? Okay, so here let's use the like previous syntaxes like what we had discussed. See, create. Okay, just use this. See, whenever I had entered this, here you can see the like like highlighted keywords, right? So these are the built-in keywords. Okay, so which SQL can automatically recognizes it. So this is a comment team. Okay, this is the comment I'm giving. Okay, let's use this syntax. Create table, table name, what we can give. So let's say, like for example, let's take one like student database, student details. Okay, with the column name, like column, what is the student ID, right? What is the data type? Int. For example, I'm giving it as a like five, only 5 digits that we can store. Int. And column to like student name. Okay, so as of now, this is enough, and our data type would be the char of uh, like 5. Okay, that's enough. So let's select this, and here you can see create option, right? Create, sorry, execute. Execute means running the query. Okay, just click on it. Then you can see command completed successfully. So this window, okay, this we call it as like results pane. Pane means pane, results window. Okay, so let me explain you in clear way. So object explorer. So this object explorer is like where we use to navigate the tables, databases, view, store, processor, and each and everything. Okay, and here this is the query editor. This is the query editor, and this is the results window. Okay, where we can see the output of the query, whatever you had performed against the database. Okay, see, let's retrieve. Let's insert the records into it. Okay, for example, insert. Okay, here I want to show one difference. Okay, here I want to show the difference of the primary key, how it will be used. Okay, and I'm just using this. Okay, let's on this one insert, right? Insert. So insert into table name. What is the table name? Student details of column name. What is the column name? Student ID, comma, student name, values. Here I'm using the same syntax. Okay, for example, one comma student name would be the like Ravi. Okay, so just execute this, select it and execute. Student name, right? Yeah. Yeah, let's execute this. Student ID and student name. See, one row was affected. Means one row got added. See, again I'm executing this. Again I'm inserting this, selecting this, executing. Again one row got affected. See, let's see same details got inserted. Like how to retrieve it. Select hashtag. We call it as hashtag. I mean star. Okay, hashtag from what table name? Student details. Right. This is the table name. So let's see. See here the details got. See here the details got. Of a student Ravi got inserted twice, right? So here using this student ID roll number, only one student should have, right? So here we got two students with the same roll number. So to prevent this, okay, to prevent this, we use the primary key 74 and this primary key mainly use it to identify unique data in each column, right? In column, right? So let's use the same example. Let's create a table with the like primary keys. Okay, let's insert the records like create a table with that. So same syntax, create table employees. Now here I'm going to use employees of with what columns that employee ID. Okay, employee ID. I'm giving the data type as int, and here I'm giving the primary key. Okay, primary key and first name. First name I'm giving it as a varchar. Okay, 10 and department. Okay, department for which department they are belong. Here also I'm giving it as a varchar of 10 and salary. Salary I'm giving it as a decimal with the precision of like for example 10 digits comma. Okay, what is the precision I can give like for example 3. Okay, uh, and the date of joining. Okay, I'm giving the data type as date. Okay, so here almost each and every data type were covered, right? So let's execute this, create table name. Okay, execute this. See now table was created. So let's insert the records into this. So insert into table name. What is the table name? Employees and of columns employee ID comma first name comma department and salary and date of joining. All right, date of joining with the values of. So let's add for example mm, 01. The first name was John and the department would be the for example HR. Let's consider like that, and the salary would be the like 50,000. Okay, 50,000 and the date of joining would be like anything that you can give. For example, I'm giving it as like this. Okay, so why I'm using this quotation marks means it would be considered like a text or a string like that. Okay, so here date also to present like that. Okay, so we are clearly giving instructions to that it is a kind of data, okay, that you need to store in that, okay, without any confusion. So click on execute. See, one row got affected, right? One row got affected. So let's see, employees. Let's execute this. Like, is that row got inserted or not? See, you can see the here employee ID is 101 and name John, department HR, salary 50,000, and with along with you can see the precision of it. 3 digits were stored, but here I haven't added that, right? Automatically it was stored, okay, and the date of joining here you can see. So at the same time, like here I'm going to execute this again how I did before for this, okay, for this how I did before. So same I'm going to insert this, okay, to show the difference between the primary key and without primary key. So let's execute this. See, violation of primary key constraint, like this primary key employee, this is the ID. So can't insert the duplicate key in the object, right? Can't insert the duplicate. So here it is. So the duplicate key value is 101. Here clearly mentioning that duplicate value is 101. So this is how this SSML tool will be like helpful to for the beginners, like we highlighting that syntax and with the proper guidance for the error messages, okay. So this is how you can use the tool, okay. And uh, and try to insert another records. I hope you got the difference between primary key and without using primary key, using primary key and without using primary key, right? So let's insert. So this is the one way to insert the records into a table. So let's try another way. So at the same time, we can insert multiple records. At the same time, we can insert the multiple records. Okay. So let's see. Let's use this the same. I'm just closing it for the. Okay. So here see what is employee ID. For example, 102, comma name Jane, and what is the domain IT, and let's say 65,000.00. I'm only adding two zeros only. Okay. And date of joining would be okay. And another record. Okay. 103 and lies, and domain would be the finance, for example, and the date of joining. Okay. Here as I haven't added the salary, right? So 60,000, right? So now that message like that highlighted was done. So instead of this also you can directly give the values like how much as you want. See? Okay. So let's execute this. Okay. Click on execute. Now two rows got affected. So at the same time, two rows, like two records were like inserted. So let's see like how records got inserted. Okay. See, like you can see all the details. So for the 65,000, I had given only two zeros after the dot operator, right? Varchar is nothing but combination of uh, alphabetic data, special characters, and numeric data. Okay. This recording will be posted. Okay. Recording will be posted. Okay. I hope you got how to insert the records. So insert is nothing but like DML command, right? DML. DML command, right? Data manipulation language. So let's try to update the records. Let's try to update the record. So existing record. Okay. Yes, automatically. So that's why I told you, right? So earlier I had given it here. It is a like after the digit, after the dot operator, it should store up to three digits only. Even though if you give below three digits, then also it will consider like it will automatically adds remaining digits as well. Okay. So let's update this. So for example, let's try to update the salary of the employee. Okay. Update. What is the table name? Employees and set. Okay. Set salary equal to 70,000, where employee ID equal to 102. Okay. So for the employee named Jane, so here I'm going to increase this, update the salary of his salary. Previously it was 65,000, but here I'm going to add the 70,000. So click on execute this. See, one row got affected, and let's see is it updated or not. See, it got updated, right? So Shazia, here you can use the Excel, like not only Excel, whenever we have the live data, okay, from there also without creating also we can get the data. So as I told you, as a BA we won't work on it. Like just it is a awareness, okay, providing the awareness like how SQL will work, what kind of operations can be done using SQL. Okay. Yes, I will share each and every documents in the end of the session. So this here I'm commenting this. This is a syntax that we need to follow. Syntax I'm here I'm for showing a reference purpose. Okay, using this syntaxes. Here you can follow the syntax and you can perform the operations. So here in the Word document I told you earlier, right? So the syntaxes that we can use and for reference purpose. So the syntax must be followed. That syntax must be followed. Then only it will consider. Okay. Can we update only one to two decimals? Is it possible for only one entry? We can update more. Okay, we can update. For example, uh, Here you can see like employee ID, like or else who department. You can also salary is 70,000, where department equal to HR. Okay, for multiple employees, you can update the value or anything at the same time. Okay, how you are inserting multiple records at the same time, you can perform the operations on multiple records. Okay, based on the conditions that we can do. Okay, and let's use the another command, and let's try alter. Okay, where we can alter the all the things, alter the table. So it is just a comment. Okay, comment, you can consider it as a comment. Okay, so alter table. So let's try to add the extra column. Previously what we have the columns like uh, employee ID, first name, department, salary, date of joining, right? So only these columns that we have. So let's try to add them one more column. So alter table, employees, add. Okay, add. I'm going to add the email column with the data type of varchar. Okay, for example, I'm giving it as a 15. Okay, so let's execute this. So let's execute this. See, now command completed successfully. Let's like let's pro. See, here you can see in the last email column got added to the existing table, right? So with all the details like null. Here also you can update the mail IDs over here. So you can use the update employees set email equal to give the value over there. Okay, email, and where employee ID equal to where employee ID equal to 102 or 103, whatever it may be. Okay, so that's how you can use the update command. Okay, and so you can change the data type as well. Here by using alter command, you can change the data type as well. So for example, let's try to change the data type of salary to float. Previously it was a decimal, right? So just try to uh, change it to float data type, where after the decimal point we can see only one digit. Okay, table employees, alter column. Again we are using alter. Why? Because we are altering the column itself, altering the table at the same time altering the column as well. Column, salary, float. Okay, so just select it and execute it. See, command got updated, and let's see like how data. Okay, here you can see, right? All got deleted. So based on the conditions that we can. Okay, see, and next we can see like here I'm using the asterisk. Asterisk means like it is selecting all the records from the table. So even though we can select a like specific column, okay, whatever you want. For example, select a like specific column, emp employee ID, okay, or else see column name. For example, only I want to select this. from employees. Okay, only I want to see here you can say only like first name and department, only these things that we can see. Okay, and also we can filter it as well, like by uploading the conditions. See for example, select star, select a star from table name employees, where department, for example I'm giving it as a department only. From the department I want to know department equal to IT. Okay, so working in the IT department, then I can see the details of them. Okay, see 102 Jane department ID star, here I selected star at hashtag. So that's why I got the details, all the details from the table. Okay, this is how you can use the select command to retrieve data in different conditions. Yes, float means this is also decimal, like while adding the, okay. So as of now, you can't see decimal points after the digit. So while if you want to see that while entering the value, salary value, there if you mention the, for example, 60,000.00, then you can see that 60,000.0 in the output. Okay, it depends on like while how you are entering. Yes, Avinash, like it's based on the conditions. Okay, if you miss one of the data, then it will be null in the table. So here I have added the email column in the last, right? Means like after creating the table, later on I have added the extra column. So at that time, it definitely shows you null value. Okay, so if not, like if it is from the scratch, then if for example, we can also set the default value as well. Default values as also. Okay, at the time also for every record, then the default value will get stored. So this PPT you can find in the document section as well. Okay, okay, I will. So and next, how to delete the rows. Okay, you can see the delete. So let's discuss the difference between delete, drop, and truncate. Delete. Okay, we can delete by applying the conditions. Okay, so delete from employees, like where employee ID equal to 103. Okay, so here I'm deleting the last record. Okay, so select a star from employees, execute it. See, third row. Okay, whose employee ID was 103 got deleted from the table, right? And also like truncate. Here I want to delete the these two, like remaining data left in the table. Okay, I want to delete all the records at the same time. So now I can use the truncate. Truncate. See, like here you can see the right truncate table name, right? So the simple syntax truncate table. What is a table? Uh, employees. Okay, just execute this. See, command got successfully executed successfully, and here you can see now the structure only employee ID for first name, department, salary, data joining, email, right? So this is how like all the records will get in deleted, uh, but the structure will remains constant. So if we use the drop, If you use the drop, then whole table will get deleted. Okay, whole table will get deleted. See, command executed successfully. Let's try to see whether the table existed in the database or not. Invalid object name employees means whole table got deleted from the database itself. Okay, I hope you are clear with this, right? This is how we can perform the operations. Like as a BA, we won't use all these things, but we use the select. Okay, how to filter the data, how to retrieve data from the database based on the requirement. Okay, these are all things that we have to know. Okay, so try to perform another operations as well on the like data. Okay, so let's discuss one another concept which is a primary key and foreign key. Okay, so here as of now you are clear with this, right? If you want to enter the details of more number of employees, then you can use the insert command, right? You can. So for reference purpose, I have shown you here. You can use this one, right? This one insert into employees. Again, you can enter. So here again you can use the this parenthesis, and again you can give the details. Okay, like this you can do. Okay, like n number of employee records that you can save over here. So just I have shown you how to enter it. Okay, is it clear, Anusha? So it will not look at the end user. So in the backend itself, it got updated. So for example, let's say Sri Krishna. So COEPD portal you are using, right? COEPD portal. See, here, like the username and password were given to you, right? So whenever you are trying to logging into system, okay, that you like username and password, so automatically your data, your login details already existed in the database, right? So at the time it will get verified. Okay, if those were verified, then only you can able to access it, right? That's how like in the backend it will get stored. Yes, each time because why? Because your unique ID is ensured for each and every employer, anything, right? Huh? So that's how we need to insert again. Yes, those are related to the like live servers, Devika. So as of now, we are using the local system servers, not the like live servers. Okay, it's not connected with any live server, as I mentioned earlier. So Krishna, that we can't say why, because like based on the requirement that we need to have the knowledge and it. Okay, so even the interface, if they ask the question, at least we need to have the knowledge on it, right? How to retrieve data, right? Because why? Because we need to work with the like developers. We need to understand the data. That's all. Okay. Okay, team. Let's continue with the another topic like primary key and foreign key. Okay. See, as of now, so it is showing the built-in keywords, right? So that's why I'm commenting this. Okay. So now let's again create the two tables. Before that, I'll let you know, like in brief, about the primary key and foreign key. As we discussed, primary key uniquely identifies each row in a table, and whatever the data that is going to store in the table, that must be unique and can't be null. Okay, cannot be null. So there must be a value. Okay, except null. And the main purpose is to identify the records within the table uniquely, and it is defined in the parent table only. It is defined in the parent table. Okay, so it is defined in the parent table. As we discussed, like customer is parent table, right? At the time in the retail store. In the retail store. So in the live server, for example, like how can I say, like a COEPD portal, it is at the time developers are working on it. Okay, so they will use this tool by connecting to the like live server of COEPD. Okay, they will direct connect with that, so they have all the data. Okay, so whatever the operations they can do, those all things will be done in the, like it will reflect in the portal. Okay, it will reflect in the portal. Okay, live data, right? Okay, so primary key. So here you can see, as I said, primary key will be defined in the parent table, and foreign key, which refers to the primary key in another table, which refers to the primary key in another table, and can contain the duplicate values, and it can be null. Okay, sometimes like unless we provide the, like keys or whatever it may be. Okay, and can here foreign key maintains the referential integrity between the tables, and it is mainly defined in the child table. Okay, child, it ensures the parent child relationship. Okay, so let's create a table, and you can understand that. So here I'm going to create the two tables with the like departments and employees. Okay, like department ID. I'm giving it as a primary key to ensure the like uniqueness, and department name, care of, for example, care of 10. Okay, let's execute this. Okay, now it got table was created, and let's insert the records into that. Okay, insert into table name, departments, and values of values. I'm giving it as a like, department ID is one, and department name is HR. Okay, again two, IT domain, three, and the finance domain. Okay, so let's execute this. Multiple records were inserted the time. So select star from departments, right? Okay, here you can say, right? So let's this is a parent table. Okay, this is the parent table. Let's mark it as a parent table. Okay, and Here, let's create another table. Create employees who are belonging to that belonging to that department, particular department. Okay. Now values employee ID with the int and primary key, and then employee name. Okay, care of 10, and can say department ID. Department ID enter. Okay, and here I'm entering the okay, foreign key of which references the departments of department ID. So here I just follow the syntax. Okay, I just follow the syntax over there. So here you can see in this document only you have. Okay, this is the syntax that I have followed. Okay, so that is for a primary key, and this is for a foreign key. Okay, so this is the syntax that I have followed. Okay, so here let's see. Right, here department like this is the table I'm going to create now. Right, yeah, command got executed successfully. So to show the difference between these tables, so here you can see foreign key. So here ensuring the relationship with the like department, this column is there, right? Department underscore ID in the table named employee is referring to the department ID column in the departments table. Okay, so here the this is referring to the this department table. Okay, here we are ensuring the relationship between them, right? See, let's insert this records. Insert insert into what is the table name employee, and with the details, for example, and department. What is the department ID? For example, I'm giving it as a 2. Okay, here it got same again, not 2 comma, and name was Bob, and department ID is related to the 1. Okay, here I'm just giving the IDs instead of giving the department names. Okay, let's see how we can read the data here. Okay, and department ID would be the 3. Okay, so let's execute insert all the records into the employee table. Okay, so let's see star from employee. So let's see the details of it, how data got inserted. Employee ID, employee name, employee department ID. Okay, see now just combining the both tables data. Let's see the output, how we can combine the data. Okay, how we can use it. So here we are, I'm using the join statements. Okay, so here I'm using the join statement. Here let me write the query. Okay, see team, here you can see, right, for example, select here I'm like selecting the specific columns from that. Okay, selecting the specific columns and department name. Okay, this is the department name from employees, employee table. Okay, uh, join, it's joining the departments table, right? Departments table on where department where this department ID equals to department ID in departments table, right? So whenever this values got matched, okay, whenever this values got matched, then only it will provide the output. So for example, here you can say, so here you're combining the both data from the both tables, right? Here we can see employee ID, employee name from this employee table, and department name from the table, right? Department ID from the first table, right? So where like it should whenever this department ID, this ID, this 2 1 3 matched with the department ID in the department ID in this one or two or other, then it directly show present the department name instead of department ID, right? So whenever it got like matched, these values get matched. Okay, so then it should present that. Okay, so let's execute this. Okay, let's definitely it will show error. Uh, So here you can see employee ID, employee name, and department ID, right? So here, for example, let's say why I said it definitely show error. If you give the department ID like same name in the both the tables, Here I had made a difference between, here I had given the underscore like a different name. That's why values like this is not showing an error. If not, for example, while I am creating the database, while I am creating the table, so if I use the same name like this, if I use the same name here in the employee table and here in the department table, then it definitely will get confused like where I need to compare. Okay, what kind of values from which column that I need to compare. So to avoid that confusion, like I had made this. Okay, I had given the different column names. Okay, even though like a relationship is ensured between the tables, right? So here you can see employee ID, employee name from the different table, and department name is from different table, right? So we are combining the data by using the join statements. Okay, this is like a little bit advanced. Like these join statements will be used whenever we want to combine the data from multiple tables. Okay, so this is how it will be. References in the syntax is nothing but syntax only. References is it refers to the this this key this table name is the right department ID. So this department ID is references to the department ID in another table, which is also a primary key. It refers to the primary key in another table, right? You got me right?